Hello, this is my submission for homework 6. Let me see, can you see these notes too? Okay, good. So our first question asks us in the MATLAB statement, just solve this data set here using piecewise linear as our first method, and then quadratic, which is also called divided difference, as our second method. So I did our computations by hand, as the question states. Our formula for our y query value, y1 plus y2 minus y1 over x2 minus x1 times the x query value minus x1. And I got that formula from here. So we do both of our different numbers, our x values that we're trying to find, the corresponding y's for. So x equals 0, that's going to be our x query, and x equals 1 is going to be our x query for our second one. So I'll just go through this one real quick. Same formula. We chose our y1 is this, our y2 is this, because our query value for x falls in between these two, which means this is going to be our 1's, x1, y1, and this is going to be our 2's, x2, y2. And our query sits right in the middle. And then we pretty much just wrote out the formula. Y1, so negative 1.1 minus 2, 0.4 minus negative 0.2 times our query value for x, which is 0, minus our x1, which is negative 0.2. We got this value. And then x1, it's the same thing, just with a different query value of 1. So the only thing that changed, our bounds also changed, because the value 1 doesn't fall in between here, it falls in between these two. So this is now our x1 and x1 and y1. This is now our x2 and our y2. So same formula, though, our values just changed because the numbers surrounding our new query value in our data set changed. So our x1 is now, or our y1 is now negative 1.1, our y2 is now negative 0.5, our x2 is now 2.1, our x1 is 0.4. Our new query right here changed, it's 1, and these are the two corresponding values that I obtained. Next problem, same data set, except we're using divided difference, which requires 3 points, which is good because we have 3 points. So what I did is I just chose these are the 1s, these are the 2s, and these are the 3s for both sets, just to kind of keep some continuity. Different formula though, so y query equals y1 plus y2 minus y1 over x2 minus x1 times x query minus x1, which you may notice is the same as this formula up here, because a step up from being linear is just being a quadratic. So it takes the linear portion and it adds to it, and it adds all of this over here, which is y3 minus y2 over x3 minus x2 minus y2 minus y1 over x2 minus x1 all over x3 minus x1 times x query minus x1 times x query minus x2. And I got that formula from here. I can't highlight it, but it's this one. And then same thing, same points, x0 and x equals 1. Just plugging in the numbers. This is our 1 column, this is our 2 column, and this is our 3 column. So you'll notice all the values correspond to that, and it's just plugging them in and solving. And I kind of simplified a little more in this one. And these are the 2 values I got. All right, let's bounce over to my code. All right, on to the code. So here's my code for my piecewise linear interpolation. It's our original data set that we were just given in the problem. Sorry, I just kind of froze reading the question. Here's our plotting for our original data set. We find our query values, kind of like what I was just talking about in the handwritten work, and then we plot the interpolation. And this is just a little addition I made to kind of get the points to kind of confirm if my handwritten stuff is right. So I'm going to run it. I'm going to show the plots at the end because for some reason I can't show my code and my plots. I don't know why it works like that, but I'll show you the quadratic and the linear plot at the end. So as you can see, here are the two values that we got, the 0.99, the 0.9667 and the negative 0.8882. And then now we'll bounce to our quadratic interpolation. So same data set, same kind of just plotting the points, except we used the interp1 MATLAB function in this one, which I learned from the solution that he posted. In this one, the difference is that we use polyfit and polyval rather than the interp. All right. So yeah, same data set and scatter in the grid and everything. We use degree 2 because that's a parabola, x squared, degree 2. So yeah, that's our MATLAB function. We find our queries just like we did the last time, except we don't use interp1. We use polyfit, or polyval, excuse me, from polyfit. And then we just plot it just like the last one. And then getting the points is the exact same, except we use polyval rather than interp1. So you pretty much just substitute interp1 with polyval, and you have to add this little polyfit above the polyval first. And now I'm going to run this. And as you can see, same points, 0.7747 and then negative 2.4721, just like we saw in my handwritten work. So I actually didn't even need to add this, I don't think. I just did it just to check my work. You can ignore it if you like. But now I'm going to bounce over to our plots. All right, here you can see my linear plot. Pretty obvious. The blue dots are from our scatter, which is just the data set. This was all given. And then the orange lines connecting the segments are from our interpolation, our linear interpolation. And yeah, if you go to x where it's 0, about as close as I can get, you'll see that we're around that 0.96 value. And then if you go to x equals 1, you'll see that we're near that negative 0.88 value. All right, on to the next plot. All right, here's our next plot. This is our quadratic, and as you can see, it's much smoother just by going up a singular degree. It's linear is degree 1, quadratic's degree 2. Cubic, which is degree 3, is better, would be better, even better than this, but however, it's not as drastic as of a increase in quality as going from 1 to 2. 2 to 3 isn't as different as 1 and 2 are. Yeah, you can see original points. You can see the curve. If you go to x equals 0, or around 0.77 where we're at. If you go to x equals 1, we're around negative 2.47. And yeah, plot's definitely smoother,
has a better accuracy, I'd say. And that's all I have. Thank you.